Okay, so we are recording now. All right, so this is the graph of the square root function, the square root of x. Whenever you put a negative in front of a function, so whenever you put a negative in front of any function, what happens is you basically reflect that function across the x-axis. So reflect means flip. So this is my standard function for square root right here. It starts at 0, 0 and curves up. If I reflect it across the x-axis, I get this type of graph right here. And this is the graph of the negative of the square root of x, right?
Okay.
And that's for any function. Okay, if you put a negative in front of the function, it flips it across the x-axis. Now, if you put a negative on the inside of a function, so this guy right here, if you put a negative on the inside, it flips it across the y-axis. So just to remind you guys, remember this is the y-axis, this is the x-axis. So negative on the outside flips it across the x-axis, negative on the inside flips it across the y-axis. Right. Now the last one is if you have a negative on both the inside and outside. Well, if you have a negative on the inside and on the outside, it flips it across both axes. So you flip it across the x-axis, then you flip it across the y-axis. So these are the 4 graphs that you need to know, okay? Now, one of the other key points to remember is that the square root function starts at 0, 0, okay? And it starts at 0, 0 because you can't take the square root of negative. So you can't take a negative x. So there's no such thing as like the square root of, say, negative 9. So you can't do that. That's why it has to start at 0, because that's the smallest number that you can take the square root of. And then the way it curves is dependent upon where the negatives are. If there's no negatives, this is the graph. If there's a negative on the outside, it flips across the x. Negative across the inside, it flips across the y. And if there's negative in both places, it flips across both. Okay. Did everyone understand how to move a graph up, down, left, right on the x-axis, on the coordinate plane?
Yes.
Yes, sir.
Okay, so what happens when I add a number to the outside? Which way what happens to the graph?
It becomes a negative.
So my question is, what is the difference between this graph versus this graph?
One you can do and one you can't do, because how are you going to add a regular number to the square root of x?
You can do that. I mean, remember, a function is a machine where you input x and then you get a y as an output. So you can do this. So let x be, say, 16. You can do that. The square root of, the square root of 16 is 4. Then 4 plus 3 gives me 7. So you can do it. It's just that how does the graphs look? What is the difference between the two graphs? Okay. So this is the graph of the square root of x. We talked about that a couple of seconds ago. Adding a number to the outside, moves it up on the x-axis that many spots. So instead of starting at 0, 0, since I'm adding 3, I'm going to be starting at 3 on the y-axis. So I'll move the graph up 3 units.
Why does it look like it's curving?
Because that's the graph of the square root function. So remember we talked about the exponential function, it being a curve. So there's most of the graphs are curves, okay? And we were going to talk about this at the very end of the square root function. And we were going to also talk about the quadratic graph, which also curves. So square root is a type of curve. Hold on one second.
No.
Sorry about that.
Doing
Neighbor's
it.
package got delivered to me. Okay, so mostly all graphs in mathematics curve. The only graphs that do not curve are linear equations. They're straight lines. So this is the curve of a square root function. Now, normally it starts at 0 on the y-axis and curves up, unless I put a negative somewhere. Now, when I add 3 to the outside of the function, so on the outside of the square root, it moves it up 3 units on the y-axis, so it lifts it up. So instead of starting at 0, 0, it'll start at 3 on the y-axis and then curves the same way. Make sense? Now,
Yes.
so if adding a number to the outside moves it up that many units, what do you think this does?
Brings it down.
Brings it down how many units? How many units?
2.
down?
2.
Right, 2. So we go down 2 units and then curves up. Make sense?
Yes, sir.
All right. Now, let's talk about what happens on the inside. So the outside is easy to understand. The inside is going to be where you're going to get confused. Now, let's talk about the difference between the square root of x versus me subtracting 1 on the inside. So this is different than subtracting or adding on the outside. This is on the inside of the square root.
We're gonna go like left or right.
Yes, it will go left and right. Now, which way will it go?
It's gonna go left. It's gonna go
Left.
Actually, you would think that, right? Because it's a negative. But the reality is that it actually goes right. So
Are
when
you
you,
talking about the first one or the second one?
yeah, the second one will go right. So when you're subtracting 1, whenever you're subtracting on the inside, it goes right. Okay, so,
But why wouldn't it go left?
okay, I'll explain that. If you add on the inside, that's when it goes left, okay? So, remember we were talking about solving equations, and we said, okay, we had a problem like this. Let me make up one. How do we solve this equation?
Oh,
Would you add the 2 on both sides?
No, remember, how do we solve these? How do we solve a quadratic, guys? What's the first thing that you have to do? You had a test on this.
on the prime.
Yeah, we had a test on this.
Factor it out.
You factor it, right? How do you factor x squared plus x minus 2?
Would you add since there's no exponent with the x, so you would assume it's like 1 and I'll give you.
Okay, yeah, 1. So what two numbers multiply to give me -2 that add to give me 1?
I didn't hear you cut out for a minute.
What two numbers multiply to give me -2, but
Mhm.
add to give me +1? What
One
am
and
I,
negative two.
no, not 1 and -2. What are two numbers? Okay, so what are my factors of -2? It's 1 and -2, and what else?
1 and -2, -1, then 2.
-1 and +2, right?
Oh yeah,
-1.
-1 and yeah, 2, +2.
So when I add these, I get -1 and I get 1, right? So which one am I going to use? Am I going to use the
Oh,
top?
I remember this because this is where you had to make the little the chart.
Right. So remember, we're going to use the bottom one right here because we want it to add up to +1.
Yes.
Now, how do we solve this? What do we do for the rest of it?
I answered the first piece. It's my turn.
Hey, I answered the first question. What you got to do, bro?
Now, how do you solve it? Remember the zero rule property that says that if you have multiple things that are multiplied together to give me 0, one of those things has to be 0.
Yes.
So that means either
It's
x.
like x minus 1 equals.
X minus 1 equals 0. X plus 2 equals 0.
Okay. So that means if I solve each equation, I get x equals 1 here, and I get x equals -2. Okay, you can remember that?
Yeah.
Okay, so here, pay attention to this. Look. Look at this. Okay. I'm subtracting 1, right? I'm subtracting 1, but guess what? I'm becoming more positive. I'm going from 0 to +1. By subtracting 1 from x, I'm actually going more positive. Now let's look at this side, right side. I'm adding 2, but I'm going from 0 to -2, so I'm becoming more negative.
Because you subtract 0.
Because I'm adding 2, right? Look, when I solved the right side, guys, look, pay attention to this thing right here. I'm adding 2, right? But when I solve it, my answer goes from 0 to -2, so it becomes more negative. Does everyone see that?
Yeah.
So adding actually makes things more negative. Here, I'm subtracting 1, but the solution is 1, so I'm going from 0 to +1. So it's becoming more positive. So subtracting is makes the answer more positive. Adding makes the answer more negative. So this is why. So this is why subtracting 1 on the inside, you move it to the right because right is positive. Because this is going to be the answer is going to be more positive. Okay. So this is why the graph will move to the right, because subtracting from x makes it more positive, adding to x makes it more negative. Negative is left, positive is right. Okay, so this graph right here, -1. So instead of starting at 0, 0, it will move right unit and it'll go up like that.
Yeah.
Does that make sense?
Yeah, because, okay, I see what you did.
Right.
I did set an alarm clock.
Okay.
Bro, can you mute yourself?
Makes sense to everybody? Subtracting from x makes it more positive. Adding to x makes it more negative. Adding to the outside moves it up the y-axis.
Yeah.
Subtracting from the
Nope.
outside moves it down.
And mute your damn self.
Does everyone understand? Okay. So let's talk about this type of graph right here. So which way am I going to move this graph?
To the left.
To the left, how many units?
3.
3. Okay. So 1, 2, 3. There we go. So, summary.
It's the D.
Yeah.
Does it matter which direction it goes in? Because I know it's negative, but like you curved it to the right. Can I curve it to the left or no? I have to curve it to the right.
It's always curving to the right unless there's a negative on the outside or in front of x. That determines the negative, where the negative sign is, determines which way it curves, okay?
Okay.
So if it was like negative square root of x plus 3, it'll be facing the arrow direction would be facing the other way.
Right.
All right.
So negative curves down. Okay. This curves left. This curves left and down. Okay. Moves up, moves up. Moves down. Moves right. Moves left. And that's all you really need to know in graphing these things. Okay. This is all of it. Up, down, left, right. Okay. Any questions on graphing? Is everyone done writing? Whoever's going to write it?
I'm good.
All right.
You gonna upload this to Google Classroom as well?
Yes, I will.
Okay.
Google Classroom and
Remind?
on YouTube.
Okay, that's me.
Yes, you're in pajamas.
Don't forget to subscribe.
Yeah.
It wasn't that funny.
Yeah, somebody's lame.
Yeah.
Okay. So let's look at a graph, this graph right here. So let's talk about what all these things do. This curves left.
Down. No. Wait a minute.
This moves it left.
Yes. Well, what about the minus 3?
I'm going to get to that. 1 second.
Okay.
And this moves down. So you need to do it like that. That makes it a lot easier for you. Okay? Just break it up into pieces. Okay. Now,
Oh, let me write that down.
yeah, I'm not going to erase it. I'm just going to graph it now.
Okay.
Just screenshot it.
True, you're right.
Okay, so left 1 unit, down 3 units, and curves left. Any questions?
Mm-mm.
Good. All right. Gonna move on?
Yes.
All right.
Yes.
You're gonna do the stuff from today?
Yeah. So
Wait, Mr. D, did you start at 0-0?
what now?
Did you start at 0-0 at first?
Yeah, you always start at 0, 0, and then move according to the equation. Move whichever way according to the equation.
All right.
Now, let's talk about some stuff that we've actually were talking about before we left class, or before we left school. Okay, how do we simplify that?
Yes. Spread it apart.
How do I, okay, so I'll first write it separately, remember?
45, 3, and
Okay, now what?
Then you
How do I,
gotta
can I separate 45?
do- you
no.
gotta do the little the tree thing. You gotta do the tree.
No, you're not gonna do the tree.
Ain't
So
you
how
gonna
do I
find
say, remember I'm looking for, if I can
Perfect.
separate it, that means that there
Oh, you
is,
gotta find two numbers to go into it.
yeah, two numbers,
one
would
that's
say
perfect square?
perfect square. Do I have, is there any perfect square factors of 45?
5.
Oh,
5 is not a perfect square.
Okay. Nope.
oh wait, yeah, 5 and 9.
9, yeah, 9 is perfect square. So, okay. Now,
Then M is gonna be M2 and then M.
right, so remember you always separate this into an even number and a single digit. So, M2 and M. Is there anything I can do with this guy
Go to M.
to the end?
Oh, no.
No, I can't. So I just have to leave it like that. Now, let's talk about what happens here. What happens to the 9?
It becomes 3.
You
Yeah.
reduce it.
What about M squared?
Just
Becomes M.
Yeah, you can reduce that too, can't you?
Right. I can't, can I do anything to these two guys? Square root
No.
of M
No,
is just being-
no.
no.
Now, when I write my final answer, what gets combined with what?
3 and M will get combined, and 5 M and N will get combined.
Perfect. Y'all remember that?
Yep.
Yes.
Good.
It was today on the lesson today, wasn't it?
All right, Daniel.
It was on, this is a part of the lesson today. Yesterday, today. We're going to go over some of the topics today as well. Now, how do we do this?
Well, that one's a fraction. You would separate it.
Gotta separate it and then put it over.
Yeah. Easy.
Okay. So how do I separate them?
48 and then
48 A3 and 25 B5.
did you go ahead and do A squared and stuff?
Yeah, now we separate the individuals. Is there any way for me to separate 48?
Mm,
No. There's no.
No.
I think about it again. Is there a factor of 48 that's a perfect square?
Can't 9 go into that?
What
No.
about 16 and 3?
47, 36. 40?
16 times 3?
Yeah, 16.
Okay. Okay. How do I separate A cubed?
A squared, well, the square root of A squared and A.
Okay, good. Now, what about 25? What happens to the square root of 25?
It goes in the square root. No, wait, no. It'll go in the 5.
Okay, and how do I separate B to the fifth?
B to the 4th. Well, square root of B to the 4th and B to the first power.
So what comes out of the radical?
Oh, on the top or bottom?
Either one.
On the top, the 16 becomes a 4.
Okay. What else?
The A on top will become, the A squared will become A.
Okay. And on the
B,
bottom, yeah.
the B to the 4th will become B to the second.
B2.
B to the second.
So when I combine my outsides and insides, I get, on the top, I get 4A root
Square root of 3A over 5 B squared to the square root of B.
Okay, now remember we talked about this also. What can we not, or what do we want to avoid doing?
Having a radical on bottom.
Okay, so how do I sort of deal with that radical on the bottom?
Multiply the radical.
Yeah, multiply both the numerator and denominator by the radical. And so remember, when we multiply with radicals, whatever's on the outside gets multiplied together, whatever's on the inside gets multiplied together. So what is the understood number on the outside here?
2.
1.
1.
1, yeah. The understood coefficient is 1. So 4a times 1 is 4a. And then the insides get multiplied. 3a times b is 3ab. Okay. Now, what happens with my square root of b squared?
What?
What happens here?
Returns to B.
It just turns to b. That was the purpose of me doing that. So the radical goes away. Okay. So what's b squared times b?
It'll be 5b to the cube.
Mm-hmm.
All right.
Any questions?
I don't think this is what I'm learning on Edgenuity. I'm learning about graphs.
Oh God.
We talked about graphs.
I'm
Basically,
gonna add
all
it.
you really need to know about the graphs is basically how you're going to plot it: left, right, up, down, curve left, curve right, curve up, curve down.
Graphing was the first thing I started doing on.
And then the next ones are going to be they're going to talk about simplifying radicals, multiplying radicals, dividing radicals, adding radicals, subtracting radicals,
That's
distributing.
what I'm doing now.
That's the
today.
next lesson.
Yeah, that's the one for today.
Okay. Any questions about simplifying radicals?
No, is that going to be like next? Is that going to be like next after I'm done with the graphs, or is that going to be like in
Yeah,
the
after the
same?
graphs, that's what you're going to be doing.
Okay.
Any questions?
No.
Okay. Right, now, how do we deal with something like this?
Just add 7 and 4 and you get your number in 3.
Yeah, we did.
It's 11 and square root of 3. That's the answer.
Yeah, right. So remember, the main thing, before you can add radicals, what's underneath the radical must be the same. So you can only add them, you can only add the outside numbers or subtract the outside numbers if what's underneath the radical is the same. So in this case, what's underneath the radical is the same, so I can just add the two outside numbers. Remember, I do not add the stuff underneath the radicals. I keep that the same. Okay, so what would this be?
Four
18
squared.
to
Not
18 square. 18 to the square root of
It's
2.
4.
Not 18.
Wait, no. Yeah,
Negative,
yeah, man.
negative 4.
Negative
negative.
4. Right. So 7 minus 11 is negative 4 root 2. Okay, so what if I gave you something like this?
Get to find what 27 has that can get like the same as 12. I don't know how to explain it.
Would that be -7? -7 to the.
No. You gotta do something. You gotta get 27 to like two numbers that multiply to get 27 and have the same number as 12.
Right. So look, guys, can I add these in the way that it is right now?
No.
Subtract these. No, I can't do it because what's underneath the radical is different. Here's a radical 27. Here's a radical 12. But the first thing you do before you add and subtract radicals is simplify each radical. can I simplify 27?
Yes, I think.
Yeah.
By 3.
So 9 and 3. Okay, can I simplify 12?
Yes.
Yeah.
So what?
3
You
and
gotta
4.
have
Oh yeah, perfect number 3 and 4.
Okay, now what happens? What comes out from underneath the radical?
4.
4
Okay, 4
4 and
becomes
9.
what?
4 and 9. The 9 becomes 4 and the 9 becomes a 3 and the 4 becomes a 2.
Okay, so 2 times 3 is now 6 root 3. And 9 times 2 becomes 18. Now, can I add these or subtract these in this case?
Yes.
And what do I get?
Oh,
get 12.
negative 12 root.
Negative 12 root 3.
Okay, so what if I gave you a problem like this?
You're still gonna have to find a number that goes in the, both of them. Or all 3 of them. Or 4.
That's grouping, ain't it?
So first, what do?
You gotta group them.
Don't group them, but you have to do first what? What do
4.
you have to do with each one of these radicals?
But you gotta find a number that goes in all of them.
You don't have to find a number that goes in all of them, but you got to simplify each
45
one
and
as much as
72.
possible. So how do I simplify 45?
9 and 3.
No, not 9 and 3.
9 and 5.
Root 9, root 3.
And how do I simplify 72?
Uh,
8 and, no, it's
What? How do I
8,
simplify
9.
8, 9? Okay. Okay, how do I simplify 20?
5 and 4.
10, 2. 10, 2.
2
Not 10 and 2. 10 and 2 are neither of those are perfect squares.
4,
5 and 4. 4 is a perfect square.
5 and 4.
2, 4, root 5.
What about 32?
8 and 4. I believe. Yeah, 8 and 4.
Okay. So what comes out from underneath these radicals? What are the numbers?
9 and 4.
All right. Now,
Ain't you going to foil?
are you multiplying in order to FOIL?
Wait, no. My bad. But you are going to have to add 2 of them, the 2 that are alike.
Now, before you keep going, you want to ask yourself, can I simplify any more of these radicals?
No.
Yeah.
8
Oh,
can
yeah,
be simplified, and 8 can be broken down into what?
4 and 2.
Yeah. 4.
Okay, and what do the 4s become when it comes out from underneath the radicals? 2. Now, which ones get combined to each other?
All of them.
3 and negative 6.
4, 3 and 4.
Yeah, so these guys, these two right here, 3 root 5 and 4 root 5, they combine and give me what?
7, 4, 5, 7.
7, 4, 7.
Okay, remember you're not adding or subtracting the inside number, you're only adding or subtracting the outside number. Okay, what else gets combined?
Negative 6 and 20.
And that becomes what?
Negative 26.
No. Oh, yeah.
Remember, negative 6 minus 20 is negative 26. Same sign at. Okay, is there anything else I can do?
No.
Okay, go. All right. Now, one last thing I want to cover. How do I deal with something like this?
Do what's in the parentheses.
Going to distribute.
Mhm.
Don't need to distribute. Guys,
Right, so you distribute everything
To
on the outside to everything on the inside. So what is my rules for multiplying radicals? What gets multiplied?
the inside.
The inside gets multiplied and the outside gets multiplied. Okay. Now, can I simplify any of these radicals?
15, I think.
I
No.
can't. What does 15 break into?
It breaks into. Well, none of them are a perfect square.
No, so I cannot simplify it further, can I? It
Not
doesn't.
15.
It doesn't matter if it can break. It can break. Yeah, even 21 can break into 3 and 7. But the problem with those is that neither of those are perfect squares, so you can't do anything more. All right. Any questions?
I can cover in. It's like having it's a 4 root 7 minus 3 root 28.
Okay, 4 root 7 minus 3 root 28. Okay. Okay. Question to ask yourself. Are all of these simplified? Or can I break down any one of these?
28.
28.
28. And what can I break 28 into?
7 and 4.
Yeah, 7, 4.
And what does 4 become when I pull it out?
2.
Radical 2. Okay. So
And then you got
what happens? 3 times 2 is?
6.
Now, can I combine these?
Yes.
Why?
Because I have the same number up under the radical.
And what do I get when I combine them?
You get negative 2 root 7.
Yeah, negative 2, 7.
Perfect. Any questions?
I got one.
Sure.
Can you scroll back up to that last problem we did?
This one?
The one before that. On the third to last step, I got confused at that part. You lost me.
Okay, so right here?
Yeah, right there.
Okay. So the main thing is you have to further simplify. Okay, I can't simplify 5 anymore. There's no more factors of 5 that are perfect squares. However, I can simplify 8. I can break that into 4 and 2 because 4 is a perfect square. Okay. So I
Okay.
can rewrite 8 as root 4 times root 2. Okay, and I can do the same thing here.
Oh, I see now. You did 3 times 2, and that gave you negative 6 for that, and then the 4 stayed the same. Okay.
Any more questions? Okay, so tomorrow we're going to be talking about further simplifying using conjugates, and we are also going to be talking about equations as well.
Okay.
All right. So if there's no more questions, have a great day, guys. Keep up with your work, okay? I'm going to be putting in the first grades, if not this evening, tomorrow morning. So please.
Mr. D, do we have any assignments due today?
Yeah, you have assignments due every day. Go look
What's
at the
the
calendar. Look at your calendar. Hold on. Let me look it up. Let me show it to you. Hold on.
This is right after what you did.
Yeah, rewriting expressions with radicals. Do you see it?
Yes, sir.
Yes.
Right here. That's due today.
That's on Google Class. That's on Google Classroom too, ain't it?
No, all of this is Edgenuity assignments, guys.
No, I'm saying ain't the schedule on.
Yeah, Google Classroom. Yeah. And plus this lecture will also be on Google Classroom as well. All right?
Yeah.
All right.
Right. No more questions, guys. Peace out. All right.
Later.